Hey everyone, and welcome back to the channel. Have you ever stepped outside on a sunny day and felt the warmth of the sun on your skin? It feels great, right? But have you ever wondered what protects us from the sun's more harmful rays? It's not magic, it's science. High above us, there's an invisible shield called the ozone layer. And today, we're going to talk about why it's so important, the threats it has faced, and the incredible story of how humanity came together to save it. Stick around, because this is a story of science, discovery, and global cooperation that affects every single one of us. So, what exactly is this ozone layer we hear so much about? Imagine it as Earth's very own pair of high-tech sunglasses. It's a thin layer of gas, specifically ozone, or O3, located in the stratosphere, about 15 to 30 kilometers above the Earth's surface. Now, this isn't a solid barrier you could touch. It's a region where ozone molecules are more concentrated than anywhere else. Its main job, and it's a critical one, is to absorb most of the sun's harmful ultraviolet, or UV, radiation. Let's break down the benefits. The sun emits different types of UV rays. The most dangerous are called UVC rays, and thankfully, the ozone layer absorbs virtually all of them. It also absorbs a significant portion of UVB rays, which are the primary cause of sunburn. UVA rays, the least energetic, mostly pass through, and they're responsible for skin aging. Without this protective ozone layer, life on Earth as we know it would be impossible. Plants would struggle to grow, oceans would be less productive, and we would be exposed to dangerous levels of UV radiation. So, in short, the ozone layer is our planet's natural sunscreen, making it possible for us and all other life to thrive. Now, let's travel back a few decades to the 1970s and 80s. Scientists began to notice something alarming. This crucial protective layer was getting thinner. This phenomenon became known as ozone depletion. The most dramatic evidence was the discovery of a massive hole in the ozone layer over Antarctica. Now, it wasn't a literal hole where there was no ozone at all, but rather a large area where the ozone concentration was dangerously low. This discovery sent shockwaves through the scientific community and eventually the entire world. Our planet's natural sunscreen was failing, and we needed to figure out why, and fast. The investigation into the cause led to a group of chemicals that were once thought to be miracle inventions. The main culprits were compounds called chlorofluorocarbons, or CFCs. You might remember them from old aerosol spray cans, refrigerators, and air conditioning systems. Also implicated were other substances like halons, which were used in fire extinguishers, and methyl bromide, used in agriculture. These chemicals are incredibly stable, which made them great for industrial uses. But that stability was also their downfall. When released, they don't break down in the lower atmosphere. Instead, they drift all the way up to the stratosphere. Once they reach the ozone layer, the sun's powerful UV radiation finally breaks them apart, releasing chlorine and bromine atoms. And this is where the real damage happens. A single chlorine atom can act as a catalyst, starting a chain reaction that can destroy over 100,000 ozone molecules before it is, eventually, removed from the stratosphere. It's an incredibly efficient, destructive process. So, our everyday products, from hairspray to refrigerators, we're inadvertently releasing chemicals that were eating away at our planet's vital shield. The convenience of modern life was coming at a very high price. The effects of a thinning ozone layer are serious and far-reaching. For human health, increased exposure to UVB radiation leads to a higher risk of skin cancers, including the dangerous melanoma. It also causes cataracts, a clouding of the eye's lens that can lead to blindness, and it can weaken our immune systems, making us more vulnerable to diseases. But the impact doesn't stop with us. It affects entire ecosystems. In the oceans, phytoplankton, the tiny organisms that form the base of the marine food web, are sensitive to UV radiation. A decline in phytoplankton would have a domino effect, impacting fish, marine mammals, and the entire ocean ecosystem. On land, many agricultural crops, like rice, wheat, and soybeans, show reduced growth and yield when exposed to higher levels of UVB. Forests and other natural ecosystems are also at risk. The depletion of the ozone layer wasn't just a human health issue. It was a threat to the fundamental balance of life on our planet. Faced with this global crisis, the world did something remarkable. It acted. The solution was born out of international cooperation. In 1987, countries from around the globe came together to sign a landmark environmental agreement called the Montreal Protocol on substances that deplete the ozone layer. This treaty wasn't just a suggestion, it was a legally binding agreement to phase out the production and consumption of ozone-depleting substances like CFCs. Developed countries led the way, and a special fund was created to help developing countries make the transition to safer alternatives. The Montreal Protocol is widely considered one of the most successful international environmental agreements in history. It worked because it was based on clear science. It set specific, measurable targets. And it had the backing of nearly every country on Earth. Industries innovated, developing new technologies and chemicals, known as hydrofluorocarbons, or HFCs, that didn't destroy ozone. It was a massive, coordinated effort involving scientists, policymakers, industry leaders, and the public. The world recognized a shared threat and came together with a shared solution. It proved that when we are united by a common purpose, we can solve even the most daunting environmental challenges. And the best part? The story has a happy ending. Thanks to the global actions taken under the Montreal Protocol, the ozone layer is slowly but surely healing. The Antarctic ozone hole, which reached its peak size in the year 2000, has started to shrink. Scientists project that the ozone layer over the mid-latitudes could recover to 1980 levels by around 2040. And the Antarctic hole could fully close by 2066. This is a monumental achievement and a powerful testament to what we can accomplish when we work together. The journey isn't completely over. We still need to remain vigilant and ensure new threats don't emerge. For example, some of the replacement chemicals, the HFCs, were later found to be potent greenhouse gases. And so the Montreal Protocol was amended to phase those down as well, showing its adaptive nature. So, what can we take away from this? The story of the ozone layer is a powerful lesson in hope and action. It shows that environmental problems, no matter how big, are not insurmountable. It highlights the crucial role of science in identifying problems and guiding solutions. And most importantly, it demonstrates the power of global unity. When faced with a crisis that threatened our shared home, humanity set aside its differences and worked together to protect the planet for future generations. It's a story we should all know and be proud of. It's a reminder that we are the guardians of this planet and that our collective actions can make a world of difference. Thank you so much for joining me on this deep dive into the story of our planet's protective shield. I hope you found it as fascinating and inspiring as I do. If you learned something new today, please give this video a big thumbs up. It really helps the channel. And don't forget to hit that subscribe button and ring the notification bell so you don't miss our future explorations. What other big environmental topics should we cover next? Let me know your thoughts and questions down in the comments below. I love reading them and being part of the conversation with this amazing community. Thanks again for watching, and I'll see you in the next video. Hey everyone!